of box in API management. You can specify limit call rates by key or by code, and you specify this as easy as that. You specify number of calls or bandwidth over a period of time for a certain.
So these are a few of the Azure basics that he is explaining through. We can just ignore these ones, just focus on maybe the theoretical part of it.
Counter key, whether IP address or subscription key. And I'm going to put a link that covers the throttling limit and access restriction policies for the API management if you are interested to review this in more details. Then the second strategy we can do is to disable or degrade the functionality. So we disable or degrade the non-essential services to allow the essential services to take place and to be executed. And the best example I would like to give in here is YouTube or any other video streaming application. When it experiences an extreme workloads, it will switch to view the videos in a lower resolution. This is to save the platform to perform other essential services or other.
Yeah, so Deva, one thing about this one. So yesterday we were talking about the token bucket filter, right? So where we were just making it wait. Like we were just making the thread or the request to wait for some time until the like the rate limit, like until we can allow it, or until the tokens are available, basically.
Yes.
So one of the things that I feel is are these strategies more about how will we handle the wait response or not? So that is one thing I wanted to explore. Like, so this is the token bucket filter logic, right? So where if we have 0 tokens left for any current request, we will make it wait until the tokens are available. So so before this, the first pattern was about rejecting the request. So simply instead of making it wait, we can simply reject the request if it is some important component that we want to preserve from affecting our overall health. So we can reject the request instead of making it wait. But at the same time, instead of making it wait, we can make it do something else, right? Or we can service it differently by short circuiting it in some way, right? So disabling or degrading the functionality, are they trying to say that maybe we will change our response or we will change the way we are servicing the request, right?
Yeah, the example that they had given, right, like for the kind of and the resolutions, I mean the resolution level, that is kind of one sample, but we can think about like a regular payload also. I think if the payload is really big, then I don't know the strategy. Like if we can have, like, let's say if the bandwidth is high, then we can return back some simple payload or some kind of strategy. I think I couldn't think like any other easiest way, but for a realistic application. But this is a good sample, like the resolution level.
Yeah. So actually, and on continuation to that, as you said, we can also combine this to the load balancing part that Molly was just saying some time ago, right? Like, what if we choose to route it to some other location on the basis of whether or not we have the available limit or not, right?
Yes.
So that is one thing we need to explore, whether like the rate limiting, which is sitting on top of the load balancing part, if that could route the request differently, the way this example mentioned.
Yeah, it's purely requirement based, like, for our side, like whatever we are implementing, right? There is a monetization involved in it. So means that, like, if like per minute we will allow only 5 calls or 10 calls. So in that case, they should have only 10 calls per minute. Like, if within that minute, if already 10 crossed, and if they are giving 11th, we will not accept it at all. We will reject it right away. But if already one of the calls got serviced, right? Then they could do. So that's the thing. But if the other case, let's say there is no monetization involved in picture, then we could allow that. I mean, we can route it to a different, in case if our gateway is like, or if we have a scalable things, then we can route it to other gateway so that they can get the response properly in case, if our system is slowing down or not responding well.
Got it. Got it. Yeah, this makes sense. Yeah. Any other doubts, anyone?
So this could be one of the throttling strategies you could do in your solution as well. And the third strategy we have in here is you can use a queue-based load leveling pattern. So what's happening behind the scene when the users are sending too many requests to our service is that our service needs to send these requests to a data store. And any data store has a limited capacity. At a certain point, the data store will not be able to execute all of the incoming requests at the same time. And at some point, the SQL will start to send failures to our service, and then we are going to send it back to the user. And if we are going to use a queue-based load leveling pattern, which is as simple as buffering the requests in a message queue, in this case, it's going to be an Azure Service Bus. And then we have an Azure Functions app on the other side that's going to be triggered for every new message being placed in the queue. And then the Azure Functions app is going to go ahead and execute these requests against the SQL database. So queue-based load leveling pattern could be used as one of your throttling strategies. And I'm going to put a link for queue-based load leveling pattern if you're interested to view it in more details. Also, other pattern you can use.
Yeah, so this queue-based, are they actually, when the rate limit is reached, then they are basically enqueuing the request, right?
My thought process, I think this is like in case if like a Uber kind of thing, right? Like they have so many requests which they cannot handle it at all. So that will run through this queue based.
Oh, okay.
Because let's say in a second they are going to get 1 million requests, right? Even though they put that much scaling. So what they are doing is like, we will give you a response right away, but it is an asynchronous mode. So they keep on getting the request, but it goes into a queue and then it goes back with the response.
So does that mean that, okay, so we might have some rate limit over consumption of the requests that are there in the queue. And as we get the request, we will simply enqueuing them, putting onto this queue, and like the rate limit that we have, or we might consume them with at a certain rate.
Yes, I mean the whole consumer publisher pattern, right? This itself they're talking about as a rate limiting, because the bandwidth or the rate of request comes in is like overwhelming, but they are definitely not overwhelming the system. Even though they say that they may give a too much request, but this service will go on. But the question may come, what if the queue itself is overwhelmed, right? Like,
yes.
Even before that, the API's contract will be affected, right? Say, for example, if you have a consistent API, which is kind of a transactional or something, which is meant for a synchronous API. If your API is meant for synchronous API, then you'll not be able to use this kind of load balancing over there, right? Because your client expects that it has to be an ID which has to be generated by your application. Then you give an async ID saying that this will be generated at later point of time.
Yeah, agree with you. Yeah, it definitely makes sense. I think not all the transaction based we cannot use it, but it depends on what is our use case. And
can you come again? Like I'm slightly it's slightly unclear to me, like your point.
Yes. So what I was saying is, usually when we're talking about a load balancer and queue-based throttling strategy, it has to be generic across. You do not. It has to be agnostic to the kind of APIs you have. Right? So as a part of your deployment, you might have some of your APIs as a synchronous based APIs, which would be like you expect you say person slash 123 where and you give a post. You expect that 123 be to be created by the server and giving back a 200 response. And the when you have that kind of a contract, the client or the guy who is making the call will be waiting for the call for the response to give him back a success response that this has been done, and that's how asynchronous API contract would work. And asynchronous, if it is by contract, if it is asynchronous, the client will understand that this is an async ID, and later point of time this will be we can check it by some mechanism. We can check whether this has been done or not. But he would know that this is an asynchronous response, and he should not be expecting all the details that this has been created. So when we have that kind of thing, if you have a queue-based thing where you say that you'll keep it in a queue and will be processed at later point of time, I'm wondering how do you it may not cater to all kind of use cases.
Yeah, I guess that is certainly a point. For like this kind of approach, we can only use for certain use cases. And not any general use case for sure. Yeah, because as even this discussion we also had in terms of the accuracy of our service, right? Like maybe we should not, our consistency should not be affected just because we are using queue, right? Few of the backend operation might fail, or maybe something might go wrong with the queue, or something might go wrong with the consumption of the request. So I guess it's given, and so far I feel that this could only be used into some use cases, not any in general use cases.
Yeah.
Sorry, Bala, Deva, you're saying something first. Then I stopped you. I think Sagar was asking you to elaborate something on that.
Yeah, I think sorry, I didn't get it. Like
I think I stopped you on the use case here, but I think Sagar was asking you about how is it being saved or something. How is it being saved into database or something?
Even I forgot.
Let's continue.
By looking at it, right? Like, I think here the asynchronous thought process is going on only on the maybe the backend service and the SQL, right? But the UI is confusing because the user is directly hitting the service layer. So
I guess this representation is slightly confusing. But this might has to do about some app server servicing our request on this side, where they have represented it by a DB or something like that. And here it could be our throttling service, it could be our like rate limiting service.
Yeah, it looks like they are using some lambdas also, the serverless functions, but eventually the messages are going and queuing in some system.
I didn't notice. Yes, definitely. So in case if they are representing it by some serverless function, so basically this is our we can actually consider this as our backend this thing, or maybe our app server.
Yeah.
Okay. Any other doubts?
Sorry, I might be reiterating because I would not attended the previous session, but did we discuss how do you make this load balancer a scalable one? Obviously, this has to be distributed. In that case, how do these guys share the state across? Say, for example, you ended up having hitting the load balancer 1 with 5 requests, and those 5 has to be taken out of your token bucket. And the 6th request is and landed up at a load balancer 2. Even the load balancer 2 needs to be aware that for this particular client type or by some particular parameter, this guy has already exhausted 5 buckets. 5 tokens out of the bucket, and the 6th token has to be taken forward now.
Yeah, so I guess just to tell you, so we are just discussing the throttling pattern. This is just about rate limiting, and this has like at least this particular pattern in this particular video, they are not talking about load balancing at all.
Sorry, I'm not even talking about load balance. Even for the throttling, when you have this system deployed in a multi-tenant mode, sorry, not in a multi-tenant mode, distributed mode.
Distributed.
So state has to be shared across, right? And that needs to be really high, low latency way of sharing the data. That's what I was thinking about. This service itself, this could be in a distributed mode, and there will be service 1, service 2, service 3. All of them needs to share the same data to understand that there are a lot of requests from this particular client, and I need to store it in the queue rather than directly forwarding the request.
Got it. Yeah. So I guess so far they have not discussed about that part, I feel.
Okay, then let's go.
Yeah, my thought process is like whenever there is like a distributed comes in, we have to have a distributed caching also. So like, if there are 4 or 5 load balancers involved, and then let's say there is 5 requests comes for a client, and if each one is taking, or like, one load balancer is taking 2, 3 requests, I think all of them cumulatively should communicate to some kind of a caching system. So that caching system will keep track of that count. Okay, is that reached 5 or 10? But I'm not sure, like I'm assuming, but we haven't yet gone through kind of how, if there are distributed load balancing involved, how it is kind of keeping the state, right? I mean, it should aware in one system.
Correct. Thanks.
But I guess this could have been the case in our other system design part, right? The rate limiting one.
Yeah, somewhere we read through this one. It's not about load balancing. Also, this could come in our any distributed thing, any distributed side. If you really want to know how the things are like in any session or any stickiness, right? We wanted to cache. It should be cached in some kind of Redis or some kind of a caching system. Yeah, this is where I think, so that it can get the common data from the cache, even though there is a cluster going on, either load balancer or any specific layer level.
Yeah, so I guess this guy is like he's using the message broadcasting way, right?
Yes.
I guess we did we had a good amount of discussion here about even the distributed cache, right? So we can have a distributed cache which might have some master slave architecture trying to maintain the consistency, or like this could be an independent service, and our distributed load balancer or distributed like if we have multiple instances for the load balancing, they could be actually referring or seeking the data from the cache. But there could be another way, like random leader selection, where they might be selecting the leader, or like leaderless way of broadcasting the message amongst multiple instances.
Got it. Again, this is mostly, it has to be in memory, and it has to be fault tolerant. I mean, it has to be really low latency. So yeah, makes sense. Just
so
if you need to have some kind of distributed cache.
Yeah, if you see, like if there are 4 hosts here, like they will be querying the same cache, and the cache might have some mechanism to maintain its own consistency, but at least it will act as a single agent. So basically this is just like having a centralized location, or just querying a separate service. If you see here, tell everyone is about the broadcasting part, like pass the message to everyone. Gossip communication, like it works on the gossip protocol again. And then the leader selection, like there was some leader election algorithm where we used to find the distance of all the hosts from all the hosts. Wherever we find the minima for the distance, we will elect that host as a leader, and that will be coordinating with every single host for any message that needs to be passed. Yeah.
Hi.
Thanks.
So,
I think this is helpful.
can you guys hear me?
Yeah.
Yeah. So does that mean that the the load balancer, right? That will be decrementing the tokens and then updating in the in-memory store as such. Is that how it works? Like,
Yep, there should
It's
be
not,
some token, centralized token from the cache, and it has to update that. Oh, I have exhausted 5 tokens out of it.
got it. Yeah. One thing I'm not sure is how do they concurrently update, right? Like the in-memory store, like when we are getting multiple requests from different hosts, right? So they have to just synchronize and make sure that's the right state that they store on the Redis, right?
yeah. So basically that's about, okay, so you mean to say, so that's about Redis part, right? That's about the cache. Like, are you trying to say how the concurrent read writes are implemented in the cache?
Yeah, just a question I had, but yeah, probably I think that's a different discussion. I'm thinking. I mean, and I also had like basically user-based rate limiting also, right? I'm not sure if that's part of this discussion, but like, does
So
that
far,
also be handled? Is that also handled as part of this cache, where for every specific user, you have to limit the number of requests. I'm
yeah.
not sure if I'm going off topic. Yeah.
Yeah, so to answer your last question, like the second question, so
Yeah.
this is a generalized rate limiting service, right? Like this is about designing any generalized rate limiting service. But as you said, we can call or we can pass on the user ID parameter. We can, like, we also call it like rate limiting on user IDs. But at the same time, we can have several such parameters on which we can do the rate limiting part. But this is more about how the rate limiting might work rather than which parameter we choose to rate limit, or
Got it.
or which on the basis, or like, so what you just mentioned is about we are throttling the request on the basis of user IDs.
Yes.
But this is more about how the throttling works, how the throttling internally works, rather than on which parameter we are trying to make it work.
Got it. No, my question is just like, does that, as a good system design, do we like handle it all those in the load balancer part, or do you delegate those requests based on user, to the backend service? How would you do that? Like, that's is it that every kind of rate limiting is done by the load balancer itself?
So far, I guess, like, yeah, that's what we were actually discussing. That could be done at the load balancer, or before load balancing, or after load balancing.
Okay.
But it's certainly not. Yeah.
Not at the service layer. Definitely
Not
not
at
at
the
the service.
backend. Yeah.
Okay, my thought process is like, since the layer 4 or layer 3 is only the IP level or the port level, we may not be able to do much on the layer 4. So definitely we need to use layer 7 in case if you wanted to throttle it based on the user ID, or let's say some of the header parameters, or some of the body parameters, or some of the attributes based on all these things. Definitely we need to handle it in the layer 7.
Usually when we talk about practical load balancers, all the practical load balancers will be L7, not at L3 or L4, because it is very hard to go into DNS and update the thing. So if you talk about a reverse proxies, or all the load balancers, what we know, I have not worked on ECS load balancers and NLB, but the regular ones like HA proxy, or any other reverse proxies, or any other load balance at that level work at L7. So
yeah, even in most of the architectures that I have seen, majority of them, like the load balancer is referred to the load balancer at L7 level. I guess there are very few use cases where we might require to implement the load balancer at network layer level.
Yeah,
it will be a lot efficient if you do it at L3 or L4, but it's equally, it is not easy to maintain that and deploy that.
makes sense. Yeah.
Yeah, and answering another question, like, I guess Mithun, you asked the question about this part, right? So far, I guess we were just discussing about how we can maintain the consistency among the host. And even if the request could be coming concurrently or like having the concurrency control in the cache, we are yet to discuss the caching part. I guess certainly if we have to, when we will be discussing about distributed cache or any other system design of cache, certainly we might be discussing how we can do it, how we can make it consistent, or how can we allow various thread to go in, how can we handle them. But so far we haven't discussed that part. Basically that is about delegating the responsibility to the cache instead of handling it at the load balancing level.
Yeah, thanks, Sagar.
My 2 cents over there is that you want this as some kind of heuristics in terms of the throttling and limiting. You don't want to make this a really a consistent system, because that will come at a cost. So you would rather go with pessimistic locking, or sorry, optimistic concurrency, that this will go through and just continue with that. I don't know. Let's check that.
Yeah.
But this may bring down the accuracy, which is the risk, or like we need to say if it is okay. For example, let's say we committed to a client that we will block 10 requests, but there's a chance that we could allow 11, or we could stop in 9 itself, because the way that the consistency works, we may not guarantee that it is exactly stopping on 10, right?
That is right. Yeah. But you might say that the contract with client would be that at least you would be served 10 requests, and occasionally you might serve more than 10, so maybe it is okay.
Yeah, kind of a class. Yeah, makes sense. Yeah.
Okay, so shall we fall back to the original discussion?
Yes.
Yeah. So so I guess I'm clear with the doubt, Deva, I guess, about the consumption of request from the queue. So shall we proceed?
Yeah, sure, sir.
Sagar, if you don't mind, just 2 cents you say how you cleared with this doubt. Sorry.
Yeah, no problem, Ani. Yeah. So like in this pattern, queue-based load leveling, like whatever request we are getting, almost every single request we might be enqueuing the request, and once we enqueued all the requests, we might have a certain way of consuming them on the consumer side. And the consumer side, we might have some we might have some periodic way of consumption which automatically consume it at a particular rate. So so this is just a asynchronous way. This is just a pub/sub model where we are just publishing all the requests that we are getting, and while consuming the request, we might have some certain rate at which we are polling, or maybe we are consuming the request from the queue.
Okay, you mean like the event looping, right? Here, what you are talking.
Yes.
Okay.
One quick thing we discussed is like this case may not be applicable for all the scenarios. I think Mithun they brought like, asynchronous versus synchronous. If there is a use case is synchronous, we may not be able to use this use case. So it varies based on the scenarios, but this is one of the way using the pub/sub model we can rate limit.
Okay. So asynchronous means we are giving to the sub thread, right?
Yeah, basically, let's say the user doesn't need any response right away. We can send them 200 OK or something, but eventually what we would do, the service will get that, and then slowly it will do, and it will communicate, do the database change or something, and it will communicate back to the users in different mode, right? Or they could roll in and get the response, or some case like that scenarios we can do it like this. But let's say there is a requirement that if user request, they wanted to right now know the response, what exactly happened with that, then this may not be applicable. We need to find some other use case or the synchronous approach.
Okay. That event looping one video is there. I will send that one. That's very easy to understand kind of thing also there. We're using queue only. I will put it in that one.
Sure. Sure. So shall we proceed? Any other doubts, Mani?
No, nothing. Thank you. Sorry for disturbing the flow.
No problem.
So many requests to our service is that our service needs to send these requests to a data store. And any data store has a limited capacity. At a certain point, the data store will not be able to execute all of the incoming requests at the same time. And at some point, the SQL will start to send failures to our service, and then we are going to send it back to the user. And if we are going to use a queue-based load leveling pattern, which is as simple as buffering the requests in a message queue, in this case, it's going to be an Azure Service Bus. And then we have an Azure Functions app on the other side that's going to be triggered for every new message being placed in the queue. And then the Azure Functions app is going to go ahead and execute these requests against the SQL database. So queue-based load leveling pattern could be used as one of your throttling strategies. And I'm going to put a link for queue-based load leveling pattern if you're interested to view it in more details. Also, other
yeah, Deva, I guess one thing we were discussing that I forgot about is we need the queue itself to be scalable, right? We need some form of scalability for the queue itself, because if the consumer is not consuming at the rate required, then certainly this might need to be scaled horizontally, right?
Yeah, makes sense. Yeah. That's the question I had, but now I think you made it clear. Like, what if this queue maxed out, right? But we need to have the scalability in picture so that even though the input is high, it can keep on storing it, but the processing will be in their own link or in their own bandwidth. Yeah.
Pattern. If you're
you were saying something?
Interested to view it in more detail.
Oh no, I was saying makes sense.
Okay.
Details. Also, other pattern you can use is to use a priority queue pattern. Usually, if you are using a message queue, messages are going to be delivered in a FIFO way, first in, first out. However, in some cases, you might have a really high priority message that you want it to be executed straight away. And the good thing about this is that Azure Service Bus supports priority queue. That, for example, when you get a high priority message, you can specify it's a high priority. So Azure Service Bus is going to place it at the top of the queue to be consumed before other messages that are already in the queue. So priority queue pattern could be implemented as well. And I'm going to put a link for priority queue pattern if you are interested to review it. And the last strategy you can do is deferring operations that are performed on a lower priority application. So as simple as we are going to choose what are the low priority services or features that our solution provides, and then we are going to stop them for a certain period of time. And let's have a look at this graph to help us understand it better. Let's assume that our service has 3 features, A, B, and C. And this is the time. And at T1, we started to hit the throttling limit. And what we are going to do in this case is we stop the execution of feature B because it's a non-essential feature. This is to allow our system or our services to continue the execution of other essential services. In this case, service A and service C. And when our resource utilization gets back to normal again, we will start the execution of feature B again. This is what we mean by deferring the execution of a certain or non-essential operation for a period of time. Also, throttling can be used for auto-scaling very well. All of us know that when we auto-scale a certain services, it doesn't scale immediately. It will take at least a few minutes for the new services to be effective. And throttling in here will help you to ensure that your system is still reliable and still able to serve user requests until the new auto-scaling services are effective. So we have time here and we have resource utilization. And at T1, we have hit the throttling limit. and we have started to do the auto-scaling for our services. But until the auto-scaling become effective, we are going to slow down the execution on these resources to try to save our system from failure and make our system available to external users until the auto-scaling resources become available. So throttling in here will help you to ensure that your system doesn't fail while you are waiting for the auto-scaling resources to be effective. Now let's talk about some considerations you need to be aware of.
So this might be about warming up time, right? So when we warm up or spin up new instances while scaling, I guess there needs to be some time, right? Like initial code start period. And then once it comes to full effect, we might need to lower the rate of consumption.
Yeah.
Of when you use this pattern. First of all, you need to be aware of throttling is an architectural decision. We already know that Azure makes it really easy for us to specify throttling limits for some services like API management or functions app. However, if you are going to follow up the strategy that's going to degrade certain services or disable certain features of your system as your throttling strategy, and you need to incorporate this early on in your system architecture and in your design phase. Also, when you apply throttling, you need to apply it as soon as possible. If you find that a particular user hits a throttling limit, you don't need to wait few minutes before taking the throttling action, because in these few minutes, the user can make really big harm to your system. So when your throttling limit has been reached, you need to apply your throttling strategy straight away. Also, it's good to let the user know that they have exceeded the throttling limit that we have specified in our system. Throttling doesn't always mean that we are under denial of service attack. It might be a genuine traffic coming from a valid user, but they are just sending too many requests to our service. And if we just let them know that they are sending too many requests to our service, probably we would be able to solve the problem before it's even started. And there is an HTTP response code, which is 429, we can use, which is going to indicate that the user is sending too many requests to our service. Last point is that we can use throttling with auto-scaling, as we have talked about already in the last slide. Now let's see when you should use this pattern. When you have an SLA for your system that you need to maintain. And in order to maintain this SLA, you need to make sure that not a particular user will be able to consume all of the computing power or resources of your service by sending too many requests to your service, which is going to affect your service to meet the SLA that you are compliant with other users. And also it will help you to handle the processing activities. If your system is expecting to get a really high requests at any point of time, throttling pattern will help you to handle these requests. Also, it will help you in cost optimization. Remember, earlier on in this video, we have talked about scaling up our resources to handle this extra workload that we are experiencing, which is going to have a more cost associated with it. So if you are implementing the proper throttling strategy, it's going to avoid you from this extra cost that you have to pay if you decided to scale your services up to the next tier. That's all you need to know about the throttling pattern. Now we are coming to the end of this video. I hope now it's clear for you what the throttling pattern is about, why it's important, how we are using it, what are the different throttling strategies you can use, what are the considerations you need to be aware of, and what are the best use cases to implement throttling pattern. I hope you enjoyed this video. If you have any questions, please put it in the comments below. And thanks for watching. Hi everyone. My name is Hassan, and in this video we are...
Yeah. Any other doubts about what we have discussed so far?
Hi everyone.
Yeah, I guess these points makes it pretty clear when can we use this one.
Quick question. Anyone knows, like, we were talking about multi-tenant, right? Is that just we have, let's say, one one microservice or one monolithic application that is used by multiple clients, right? That's the mean, or that's the thought process, right? So that like we could potentially say every client should have equal usage. Then we say that we can assure that every single tenant is sharing the bandwidth properly. Otherwise, like if you are opening up or if you don't have uh, s- uh, any segregation, then there's a potential chance that one client could take all the resources by having a multiple request calls, right? Or is there any hardware property involved if we say a multi-tenant or a single tenant like that?
So from last discussion that we had on the same thing, Deva, I understood it this way. So let's say if any cloud service, we are talking about any cloud service, right? Um, let's say there is one client. So, and if we want to have that client to have the cloud resources to be isolated, some sort of isolated environment where there might be some dedicated hardware, as well as some form of dedicated, like some form of compartmentalizing the resources, so that those resources will be used by this particular client, or all the services that are associated with this client ID, then that we call as single tenant, right? And there could be a generalized hardware where, let's say, we have multiple clients which might be sharing those resources. So let's say we are talking about in terms of resources. If we have dedicated resources, then we can call it single tenant, or uh, or if we have shared resources, then we can call it multi-tenant.
Okay.
But the basic tenants, basic requirements of a multi-tenant system is that you manage your deployments across multiple tenants, but make sure that they are not aware of each other, in the sense, this is a classic case, right? One
Yes.
guy
Yes.
trying to get all the reads, trying to be greedy and put heavy load on the system. At no point that should not affect the tenant two who is who is using at a moderate speed. So that's
Yeah, so I guess there are some side effects for that as well. So there are this noisy neighbor issues, right?
exactly.
Or bad neighbor issues, which can cause which can affect our SLAs as well. So of course that needs to be taken into account as well.
Okay.
So let's say if for some certain resources, if there are 10 tenants out there, and let's say some particular service might need to scale more than their capacity right now. So that might run into some issues for the other ones, like some kind of availability issues for rest of the tenants, that we call as noisy neighbor issue. So there could be possibility for that as well in multi-tenant services.
Okay. Okay.
I guess the primary goal of having multi-tenant services could be cost optimization, or just lowering down the overall cost of our infrastructure, I feel.
Yes. Yes.
Like if there is some special use case, or we want to have some secure environment, then I guess we can go for dedicated single tenant usage as well.
Okay. Got it.
I think in practical purposes, it makes sense to go with a multi-tenant system if you are having more than one client, because not all the clients will be sizable. Let's say, for example, if you ask for one service from Amazon, unless it is sizable for them, it doesn't make sense to create a new set of deployment IDs end to end for you, just for you.
So
So
is
that
that
is,
mean, sorry, go ahead.
go ahead, Deva, go ahead.
My thought process is like, is that mean the so that bring a picture, let's say it's not always cloud. Let's say I have like an on-premise one data center and I have one application running, right? Let's say that application, I have like 2-3 clients wants to use that application. It's a simple Spring based or like small application deployed, right? And let's say that application needs to be used by 3-4 different clients. Then we can say that application is supporting multi-tenant. Is that a right word to say? Or the application should handle, or it should have some their own
If
implement.
if these 3-4 clients are not sharing the data, if each one of them has their own data completely different from each other, if they are not collaborating on the system, then you can say that, I think.
Okay, makes sense. Okay, because that the thought process I had previously was like multi-tenant always like a hardware. I mean, we kind of cloud-based. We put a separate hardware, or we use multiple like AWS. Like they may have a bigger virtual machine, and a lot of clients could share that. Is that the thought process, or like, yeah? The term says I think multi-tenant. I think as long as we don't share, even though multiple clients uses that system, we need to make sure that data is not shared. But do we know that is there any, let's say is there any protect, or the way, let's say I'm writing my code, right? Is there any extra things that I need to make sure so that the data is not shared? Or like, then my thought process is like any Java application, it is like it is a multi-tenant application, right? As long as each client's data is coming properly and saving in a separate table, or properly protected, right? When we write the code, or how it is getting persisted in the backend.
I think separation of data is one aspect of it, right? So, and that separation itself would also, I think the word multi-tenant is a kind of slightly it's open for interpretation.
Okay.
And there could be different levels of implementation of the same multi-tenant system, right? Like you said, one way is to completely create a new set of clusters, new set of databases for every new tenant. So that could be the most clean, the most easier way to tell that these systems are completely isolated from one another. The other way is that you, as you said, somewhere at the software level, you make sure that if the request is coming from tenant A, you go to a separate table, whereas the tenant B go to a separate table, and so on. That way you can achieve multi-tenancy. The third way is that you can even store at the same database, the same table, but still segregate them based on the row level security or some kind of mechanism.
Okay.
So I think it's all depends on how strict you want to implement this, and how flexible you want to have in terms of the effort you are doing.
Okay. Got it. Yeah, makes sense.
I guess, and partly the security problem could be handled through our authentication mechanism or authorization mechanism. So meanwhile, we were talking about the context, right? The bounded context, Deva, do you remember?
Yes.
Domain based or fine-grained scopes, or this thing, right? So recently I was looking at auth context types. So there are ways to create a service to create a system like authorizations system, where every API or every resource that we are consuming might have some scope enforced onto it. So if even if any malicious request comes in, even if any cross scripting happens, we can still have some signed mechanism that we can verify all the time whether or not this user who is requesting some resource has the permission or not. So in terms of multi-tenancy, that makes sense, because if someone tries to send some malicious request, or someone who is not like any unauthorized agent want to request any resource, he that all those requests will be rejected right away, because we might have some mechanism to verify the scopes which might be signed through some token mechanism, or we might have some IAM service enforcing that verification.
Yeah, that's correct. So yes, in some of the gateways or API gateways, we have like the scopes also. Like usually what we do, we provide a role. So if anyone having that role, they can access the APIs, right? But at the same time, this is kind of the role is like a top level access, right? but sometimes we use the scopes also, so that specific endpoints can be used by a particular user who is having this role and this scopes.
Exactly.
That comes through the OAuth token. Yeah, the JAR tokens.
Yes, exactly. So OAuth 2 specifically deals with these issues.
Yes, yeah.
Any other doubts, anyone? Okay, yeah. So if this is okay, we can actually move on to the further discussions, right? So I guess we talked about gatekeeper pattern. We also covered the gateway aggregation pattern, right? If I remember correctly. I guess we did cover this, right, Deva?
Yes, we covered.
Yes, we covered.
Okay, yeah. So yeah, I guess this one's why we need to segregate it to a gateway. Yeah. So the one the next we can start with is a gateway offloading pattern and gateway routing pattern. Yeah. So for tomorrow, I guess we can have both of these, or we can try to complete the ones in continuation with the throttling pattern, which could be queue-based load leveling and priority queue pattern as well. So according to you guys, like, can you have any, can you give me any suggestions, like which I'm okay with both of these, just because we have current, like in current context, we can go with these ones as well.
My thought process is like, since we already just gone through that the queue based and the priority one, we can take the other two and run through that to see how that differs, and then maybe come back. But I'm good with just my thought process, but I'm good with what everybody agrees upon.
Okay, yeah. Any other ideas, like any other opinion? Okay, yeah. Well, then we can go with the queue-based load leveling tomorrow, and then afterwards we can go with priority queue pattern as well. So these two for tomorrow.
Yeah.
I guess let's cover publisher subscriber pattern again with the in continuation with the priority queue as well, or the queue-based. Okay, yeah. Shall we stop here?
Yeah.
Thank you, everyone.
Thank you all.
Thank you.
Thank you.